to 2b on page 5, and we factored the bottom first, and then we used what we see in the bottom to test. Okay, so we looked at x plus 4 and thought, well, maybe x plus 4 is a factor in the numerator. If so, then negative 4 should work in the little synthetic division box. How will I know it does work? If the remainder is 0. So that's what I'm hoping for, right? Let's run through the synthetic division again. Bring the 1 down. Multiply negative 4 times 1. Add. You get 0. Multiply. You still get 0. Add. You get negative 1. Multiply negative 4 times negative 1, and you get 4. And then when you add those, you get 0. So that's your remainder. So it turns out x cubed plus 4x squared minus x minus 4 does factor into x plus 4 times, okay, this was the x cubed column. Now it's 1x squared. This was the x squared column. Now it's no x. Right, because there's a 0 there. Oh, we don't even need that. Minus 1. So the other factor is x squared minus 1. Pause and just at the beauty that is math right there. Go ahead, tell me, Sam, what does that factor to? Okay, x plus 1 and x minus 1. So that green thing becomes x plus 1 times x minus 1. That blue thing was x plus 4. The blue thing's on the bottom, x plus 4 and x minus 1. So as you're sitting there looking at this fraction, you're like, whoa, not only do the x plus 4s cancel, so do the x minus 1s, right? These cancel, creating a hole where negative 4 blank. I always leave that blank and come back to it. These cancel, leaving another hole at 1 blank. We'll come back to it. Everything in the denominator canceled, meaning that all I have left is x plus 1. So technically, since that x plus 1 was in the numerator, we would have our x-intercept at negative 1. And it has no vertical asymptotes because nothing was left in the denominator. Back on the video here, we decided to graph this problem. 2b, try it 2b on page 6. This isn't it. I didn't enter it yet. So let's go to y equals, and let's go ahead and enter the function in y1. Here's the original function, and when I hit graph, it just looks like a line. So there's no vertical asymptote because there was no denominator left. Once we reduced it, there was no denominator left. And we thought that there were going to be holes in the graph. Am I right? We thought the holes in the graph would be at negative 4, comma, not sure yet. I think it's negative 3, though. Right? Because when you put negative 4 into the purple function that remains, what's negative 4 plus 1? Negative 3. And the other hole will be at 1, comma, 1 plus 1 is 2. So I ask you this. When you go back to your graphing calculator and you press trace, negative 4, enter, is there a y? Trace on the original function, negative 4, enter, is there a y? No. But do you think it's at negative 4, comma, negative 3? Does it look like that blue line would go through that point? Negative 4, comma, negative 3? What about when x is 1? Go ahead and hit trace 1, enter. Oh, there's no y value again because 1 would make your denominator 0. But where do you think it is? Looks like 1 comma 2, right? What if we graph the equivalent function in y2? Will it have valid values at -4 and 1? Yes. Graph it. Now that I see that red and blue are a match, I think I did this correctly. And if I hit trace on y2, now -4 returns a y value of -3, and 1 returns a y value of 2. That's where the holes were. By the way, what's the x-intercept? -1 comma 0. Okay? That concludes problem 2b.